Hi, everybody. Welcome to the course Introduction to Deep Learning. My name is Aparajit, and I'll be going over the logistics of this course. So, one of the reasons why you guys would have taken this course is the term neural networks. Neural network has become one of the major thrust areas in various problems in today's world. Almost everything is actually influenced by neural networks now. It has also established state of the art results in many problems, often exceeding previous traditional methods by a large margin. Some example which you guys use in your day-to-day lives are your personal voice assistant like Siri, Google Home, Cortana, etc. These neural networks work on speech recognition. The next one is object detection, where an input image is given to a neural network and it detects the various objects present in the image. This is a neural network called Detectron 2 by Facebook Research. Yeah, another hot topic which is prevalent in today's world is self-driving cars, where a neural network is trained to help in driving a car by itself. So this is actually a video from Tesla, and the link is given here. Another interesting application of neural networks is OpenAI's Jukebox. This neural network generates pop songs or any genre songs sung by singers who are not alive now. Like, for example, Frank Sinatra, Elvis Presley. So that's kind of cool. You can take a look in this link. They have some audio files with songs sung by Frank Sinatra, Elvis Presley, and so on. Yeah, even a different genre song sung by Katy Perry. Another application is text to image generator. So DALI is the model which is used for it. I use this link to generate these images. So in the input which I gave for it for this model is guy standing on a flying car, which is which is an absurd thing to say because I don't think anyone has ever seen a real image of a guy standing on a flying car because flying cars are non-existent now. So I just wanted to make it hard for the neural network, and it was actually able to do a pretty good job generating the image of a guy standing on a flying car. So not just that, neural networks have been successful in various other problems from astronomy to healthcare and even predicting stock markets. So the staff of deep learning, like a lot of memes, and this slide actually tells you that at the end of this course, if you do everything properly, you'll most probably be the person on the right. So moving on to the course objectives at a higher level, we'll be understanding what neural networks are, comprehending the models that do previously mentioned tasks, and even try to build them like for object detection, speech understanding, and so on. Familiarity with some of the terminologies. This link actually has a lot of various neural network architectures and so on. You can have a fun read and fearlessly design, build, train neural networks for various tasks. Fearlessly design, as in at the end of 4 homeworks, you will be able to deploy, you will be able to design neural networks, train them for any application. But it is to note that you won't become an expert in one course, but you can say that we'll prepare you for the better part. So moving on to the mid-level, we'll be exploring some historical perspective, that is how neural networks were inspired from biological neurons, types of neural networks and the underlying ideas, learning, training, practical issues, various architectures, applications. And Professor Bikshaw's slides are more focused on helping the students understand the concepts, which we think is more important. Practical implementations are like familiarity with training, implementing various neural network architectures, implementing state-of-the-art architectures for your homeworks and your projects. At the end, we aim to set you up for further research or work in your research area. So moving on to topics, we'll be covering multi-layer perceptron, which are basic neural networks, convolutional neural networks, which are neural networks for images, recurrent neural networks for speech, Boltzmann machines, which are loopy networks, and some advanced formalizations are generative models, adversarial models, graph neural networks. Don't worry if these terms don't make any sense. At the end of this course, it will. Topics which we'll cover upon are computer vision, which is neural networks on images, text processing, machine translation. An example is language translation, model distributions, generating data, speech recognition, and most probably reinforcement learning. This will actually be a guest lecture. Last semester, it was actually by Dr. Reshmi Ghosh from Microsoft. And you will actually have a list of books on the course website. Additional reading material will appear as the course progresses. For each lectures, we'll actually upload additional reading materials. So please take a look at the course website. So the instructor for your course will be Professor Biksha. His contact information is given here. The TAs list is actually given in the course page. We have TAs from Pittsburgh, Silicon Valley, and Kigali campuses. We have around 25 TAs, if I'm not wrong. There are remote and in-person office hours, but these are subject to change. Any change will be announced on Piazza, which is our go-to discussion forum. The lectures are always in person unless rules are changed due to COVID. The in-person lectures will also be recorded. It will be live streamed for remote sections. Recorded videos will be uploaded either on YouTube or MediaTek or on both. It is important that you view the lectures even if you think you know the topic, because we have marks for viewing the lectures, that is attendance marks. We'll discuss more on this later. So in any event the lecture is moved online, we'll expect you to watch pre-recorded lectures from the prior semesters. You'll be notified on Piazza regarding this. So additional logistics are Piazza. For new fall 22 students who do not know what Piazza is our discussion forum where students put forth a lot of questions and VTAs and the instructors answer it. Everything happens on Piazza, so please be updated with the recent threads. Computer infrastructure will be required by every one of you because model training is not a joke. Everyone gets Amazon coupons. You will actually get a coupon for like $50 first, and additional coupons or tokens worth up to $150 will be given to you for your course. You can use it for your homework and your projects. So lecture attendance, as I told previously, you have marks for attendance. So what we have noticed is that course scores and attendance are proportional to each other. People who don't attend classes tend to get relatively lower scores. And there's also an inverse correlation between attendance and the amount of help you require on Piazza or during OH. To encourage attendance, we assign 1 mark for attendance. So it'll actually be 1% of your total grade if you're in the graduate section, 1.3% of your total grade if you're in the undergrad section. And believe me, this will be the difference between an A and a B. So more on alternance in the next slide. So you must either attend the lectures in person or see the streamed video with some exceptions. We get attendance stats from your participation in-class polls. The in-class polls will be hosted on Piazza, so it is recommended that you install the Piazza application on your Android or iOS phone. You can also use the Piazza on your web browser if you're undertaking via Zoom. So apart from answering the polls, you shouldn't be using any electronic devices during the in-person lectures. Students in Silicon Valley or any other campuses who are stuck in bad time zones, like for example before 8 a.m. or after 5 p.m. for the class, may alternatively watch recorded lectures on MediaTek. MediaTek records who watched for how long, and you must at least watch for 70 minutes to get the attendance. And you have to watch the MediaTek lectures before the next week's Monday, 8 a.m., or else you won't get an attendance. At the end of the semester, we'll select a random subset of 50% of the lectures and tabulate the attendance. If you have attended at least 70% of these randomly chosen lectures, you'll get the attendance point. This is subject to change. Schedule is actually given on the website. It might be a little fuzzy for the later half of the semester because of guest lectures. Guest lectures will be given by some of the few mentioned here, or it will also be given by Professor Piksha, student from the industries. We had guest lectures from Microsoft, JP Morgan and Chase, in the previous semesters. So recitations, we have 14 recitations excluding boot camps. Boot camps are more focused on homeworks. So you'll have recitations every Friday, and we'll cover implementation details, basic exercises, which will definitely help you get started on homeworks. It is very important that you attend all the recitations, even if you think you know everything. It'll actually help you solve the homeworks a little easily. Uh, the topic list is actually on the website, the course schedule website. You can take a look at it. Going on to evaluation, we evaluate your scores based on weekly quizzes, homeworks, and team projects. Team projects are not for the undergrad section, which is 485. Going on to weekly quizzes, you'll have 10 multiple choice questions for which you'll be given 3 attempts. The questions will be covering topics from the slides and in the lectures. It'll be released Friday night and will be closed Sunday night, but this will occasionally shift, so please don't panic about it. There'll be in a total of 14 quizzes, and we'll consider the best 12. The reason why we do this is because there might be some students who might not be able to do quizzes because of some unavoidable circumstances. So you could skip 2 quizzes. So moving on to what quizzes have, slides contain a lot more information that is actually presented in class. It'll actually have hidden slides. So quizzes will contain questions from topics that are on the slides but not presented in class, that are hidden slides. Will also include topics covered in class but not on online slides. Quizzes will also contain questions based on research papers. So the links to these papers will be shared during the quiz. Going on to homeworks, there'll be one early homework before the start of the semester to prepare you for the course, which is homework 0. This is for students to get to know more about Python, NumPy, basics of PyTorch, and so on. Homework 1 to 4 are the actual neural network exercises. All homeworks from 1 to 4 will have 2 parts. Part 1 is the auto-graded problem with deterministic solutions. You'll be uploading your solutions onto AutoLab. Part 2, the interesting part, is the open problems posted on Kaggle as a competition. There'll also be bonus homeworks, 3 bonus homeworks corresponding to homework 1 to 3, and 4 separate autograd bonus homeworks. So you have to note that these marks won't contribute to calculating the final cutoffs or the final grading curve, but it will give you a chance to make up for any marks which you have missed. So what are homework part ones? So part one of homeworks evaluate your ability to code neural networks from scratch. So it is basically building up your own neural network with just an NumPy library instead of any other toolkit like PyTorch or TensorFlow and so on. So at the end of all homework part ones, hopefully you will have all the components necessarily um, construct a little neural network toolkit on your own. We call it MyTorch, which rhymes to PyTorch. So these homeworks are auto-graded, so please read the instructions carefully. The auto-grader is set up on a computer with specific versions of various packages. Your code should definitely adhere to those restrictions. If not, you will get 0 errors or 0 marks, even if it runs perfectly on your computer. So we'll provide you a requirements text along with all homework part ones. Make sure that all the packages which you have in your computer is similar to what is there on that. And you also have an early submission bonus, which if you submit this homework part one before an early submission deadline, you get some bonus marks. So moving on to part two. Part two of every homework tests your ability to solve problems on real world data sets. There's an early submission deadline which is mandatory. It's not a bonus, it is mandatory, and it is worth 10 out of 100 points which you get. The reason why we have this early submission deadline is because some students tend to start this part two just 2 or 3 days before the deadline. And believe me, models for some homework might even take a day or two to get trained, and we don't want that to happen for students. And the remaining 90 points are actually determined by your final scores. There are four cutoffs after the earlier, like 10-point ESD. The first one is high cutoff, which is 90 points, medium cutoff, 70 points, low cutoff, 50 points, very low cutoff, 30 points, and no submission gives you 0 points. Your score is linearly interpolated between the cutoffs. So, example, if uh, if we said that 85% accuracy model is for the high cutoff and 75 percentage model is for the medium cutoff, if your model gets 80% accuracy on Kaggle, then you will get 80 out of 90 points. So the marks are linearly interpolated. There's also a fifth bonus cutoff for extra credits, which will be 10 points or 5 points, and it is determined by the highest scoring student. So, for example, if the Kaggle leaderboard, Kaggle topper has an accuracy of 92%, this student will get 110 out of 100, and anyone getting between 85%, which is the high cutoff, 85% to 92% will get marks ranging from 100 to 110, considering that they have completed the early submission, mandatory early submission to get the 10 points. Moving on to the homework deadlines, there are multiple deadlines, separate deadline for the part ones, and Kaggle component has multiple deadlines. You have the early submission deadline, which gives you the mandatory, which is the mandatory submission worth 10% of your part two. The on-time submission, your final submission must occur before this deadline to be eligible for full marks of your cutoff. Late or slack deadline or the drop dead deadline. Submissions after the on-time deadlines will receive a penalty, but you can actually use slack days to avoid a penalty. But you can't get a bonus if you use slack days. Everyone gets up to 10 slack days, but it does not apply for the initial early submission deadline or part one of the homeworks. You can distribute them across all your homeworks, but in total, you just have 10 slack days. When you use slack days, you become ineligible for the fifth cutoff, which we discussed, or the A plus bonus. So, A plus bonus for that homework. Once you use up all your slack days, any submissions after that will cost you 10% penalty. And we won't accept any more submissions after the drop dead deadline, which is the late or slack. And Kaggle leaderboard stops showing us our dates after the deadline. So we won't, even though you'll be able to see your scores, we won't be able to see your scores. But we'll actually continue to accept submissions until the late slack deadline using another Kaggle. So please be aware of it. And we'll post more about the required Slack Kaggle on Piazza, and also see the course page for a complete set of policies. Course project. So if you're taking the graduate version, you'll be required to do a course project. 685 students will be required to do a fifth homework that is equivalent to a project. Projects are done by a team of four. 685 teams are ideally two person teams, and you are encouraged to form your teams early. Projects are intended to exercise your ability to comprehend and implement ideas beyond those covered by the homework. So you will be implementing cutting edge ideas from recent papers, verifying hot published works, um, do good researchy problems that might even possibly lead to publications, propose new models, new architectures, new techniques, and so on, etc., and new evaluation, etc. So try to form your project teams as soon as possible. If you don't get a project team, don't worry, we will team you up. Each team must submit a project proposal by the end deadline listed on the website. You'll also have to submit a midway three-fourth project report through the semester. Submit a preliminary full report 3 days before the presentation due date. The presentation is usually a 5-minute video at the end of the semester. It can be presented by one or some or everyone in the team. It will be evaluated by the instructors, TA, and also your classmates. Make sure you explain your problem, the solution, evaluation clearly. And this presentation might not be as easy as you think. Poor presentation can significantly affect your project score. So just be careful of it. And you'll also need to submit a final full report at the end of the semester. defend your projects in front of your peers, TAs. All information about the projects will be updated on Piazza in the later half of the semester. Each team will also be having a TA mentor who will monitor the progress and assist you if possible. The project is often the most fun portion of the course because in those few days when you put up your video presentation and your peers, instructors, and TAs ask you a question, you'll get the experience of actually being inside a conference, and you are trying to defend your project as much as possible. So it'll be really fun, guys. So this is the grading scheme given. So you have 12 quizzes, each 2 marks, which give 24 marks in total. The part one and part two, including for each homework, gives you 12.5 marks. So all the assignments, all the homeworks give you 50 marks. The project is for 25 marks, which is not for the undergrads. This binary multiplier is actually based on how each member contributed to the team. So, if one person doesn't actually contribute to the team as much as everyone, then it is highly likely that that person will get a lower project score compared to the other ones. Note that there's also 1 mark for the attendance. So, preparing for the course. The course is implementation heavy. There's a lot of coding. You'll be needing to do a lot of experimentation on a lot of models to get to the medium or high cutoff. You'll be working on large data sets from Kaggle. So it's just to warn you beforehand. We'll be using Python, and the toolkit of choice is PyTorch. You're welcome to use other toolkits, but the TAs might not be able to help you with it. Some of us support TensorFlow. We hope you have gone through Recitation 0, Homework 0. Homework 0 carries no mark, but it really helps you to get prepared for the course. So please do it and watch Recitation and do Homework Zeros if you haven't done it yet. We believe that going over this course as a team is the most beneficial, and we definitely encourage that, but there are some strict rules. We advise you guys to form your own study groups. If you don't form your own study group, please register to the form on Piazza. There'll be a form posted on Piazza. So we'll give you your own study groups. Everyone must be a part of a study group. Each study group will also be assigned a TA mentor for help throughout the course. This is one of the best resources which you can get, a study group mentor. So what study groups may do, you can discuss homework problems, solutions, discuss papers, classwork, quizzes. We encourage you to meet and discuss ideal work regularly. You can also, study groups can also be go on to form project groups, but there are some caveats to what you shouldn't do as a study group. You may discuss questions of quizzes with your study groups and friends, but when you solve it, you'll have to isolate and do it yourself. Every student must solve the homework by themselves. You can discuss the homework with your friend, even help them to debug the code, but when you finally solve it, every line of code must be yours. Your solution must be yours. And taking code from the web or your friends is definitely cheating. And please don't cheat or take anything which you haven't done it yourself. Be sincere to yourself. So you are here to learn deep learning by yourself and not to demonstrate how well your friend or some random guy on the web knows deep learning. If you are here at CMU, that means you are one of the best students in the world. So if you actually start cheating now, it'll be an insult to yourself and everything you stood for, and you'll be actually lowering your own standards. So please don't cheat. If you are in a pickle and do not know if what you're about to do constitutes cheating or not, please check on with us. We are always here to help you. Moving on to mentoring, each study group will be assigned a TA mentor who will track your progress, and you can actually reach out if you think that you are in trouble. This is one of the best resources which you can get in this course. If you're in trouble, please reach out to your TA mentor or the instructor, Professor Biksharaj. If you're falling behind, if you're struggling, if you're pressured, unable to cope up, don't worry. Please reach out. We will try our best to help you. The TAs and Professor Piksha, we are all supportive of you. We want you guys to enjoy this course as much as possible and do work at the same time. Please watch Recitation 0I if you're feeling overwhelmed. So we aim to make this course successful to everyone, and in our ideal world, everyone performs well enough to get an A. So without lowering our standards, we like to bring you all up to where we believe you deserve an A. So everything about this course is geared towards that objective. This course is not easy. It has a lot of work, lot of work, lot of work, lot of work. It's not for chicken, but it is definitely fun. You enjoy a lot in this course, and personally, I felt immensely happy after the end of the semester because I felt that I learned a lot in this course. So after 3 months, you will definitely feel the same. And it is also calibrated that to ensure that this course is doable. And we found out that over 60% students get some flavor of A in the past 3 semesters, and they deserved it. So our evaluation is mastery based because quizzes actually help you understand the topics covered in the lectures. Homeworks teach you to implement complex networks and optimize them to get high performance. And projects help you get exposed to real world problems. So the target is anyone who gets an A in this course is ready for a deep learning job. So I can't stress this more further. If you haven't watched Recitation Zero or haven't done Homework Zero, please go and watch it. Watch recitations, complete the homework. These are definitely necessary for you to gain comfort in Python, NumPy, PyTorch, and will make your life easier in the course. Part 1 also has many components which are intended to help you later in the course. It might be a little dense, but don't worry, it'll be worth it. Homework 1 is the easiest, so every homework after that will start to get difficult. But don't worry, we are here to help you have a good journey. So if you have any other questions, please post on Piazza. We'll be happy to help you. In conclusion, thank you for deciding to take this wonderful journey of deep learning with us. And I guarantee you that at the end of the semester, you will feel that you have learned a lot from the semester, and it will turn out to be one of the best courses which you have taken. So thank you for watching, guys. We'll see you in class.